I need you guys to pull up, not this week's module, but last week's module. Momentum intro worksheet. Here it is. We worked on it. You guys did the first 3 problems. You should have it somewhere in your notes. I'm going to show you guys how to do that 4th problem there, how to do the 2 objects problem. I would really look in your guys' notes because I know last week we went over it together. Here's the Dropbox for it. I'm going to have you guys put it in when we are done. Let me get it up on the iPad and all correct. This might take a minute here, guys. So this is what we're looking at, and I'm going to show you how to solve them, but really I want you guys to pay attention to my construction of the bar chart. That's what I am most important with, most worried about here, is the most important part. We are going to solve a bunch of these types of problems, and there is a process to them, and the process begins with drawing some sort of picture, some sort of initial and final state picture with all the information on it is also important. So I kind of just make my I, make my final, get some sort of picture-like chart going on here. So in the beginning, Clayton, mass 80 kilograms, runs down the field toward the goal line at 6 meters per second, and the defensive tackle is running in the opposite direction. So initially, Clayton. And then under the picture, I like to put the information. And here is our defensive tackle. And his mass is 155 kilograms. Come on. And he's moving 3 meters per second. Now, what you guys have to remember is that one of these velocities has to be negative. They don't say which one's positive and which one's negative. To me, in football practice problems, we get enough of them towards the goal line positive, away from the goal line negative. Makes the most sense to me. So we need to write that our defensive tackle's velocity here is negative 3 meters per second, or else the problem does not work really whatsoever. And then in the final, you just kind of draw these 2 guys having collided with each other, and we don't know which direction they go in yet. So if you just drew the picture, guys, it wouldn't really give us any information, but like this kind of is a picture and a given section for all of our given values here. So the next step is to draw the bar chart. And the bar chart starts with an equation. The initial momentum of object 1 plus the initial momentum of object 2 plus any changes in momentum impulses, excuse me, equals the final momentum of object 1 plus the final momentum of object 2. Once I do that, I section off the middle part, make a positive and negative side. I want to put that a little farther down. Make a positive and negative side. And then start to fill in values. And what I'm really doing is initially, especially filling in the momentums. If I have the momentum there, you guys know by now that momentum is mass times velocity. I'm not going to do all this math out for you. Mass 1 is 80 kilograms. Velocity 1 is 6 meters a second. Momentum 1 is 480 kilogram meters per second. For the second object, he is 155 kilogram mass, and he is moving at negative 3 meters per second. If I multiply that together, that's negative 465 kilogram meters per second. There are no changes in momentum because there's nothing coming from out of the problem, out of the system in order to affect the system. And we're actually going to work on isolated system momentum bar charts before we talk about impulses in a non-isolated system. So I basically, once I've made my bar chart, I don't know what goes on this side yet. That's kind of how far I can get right now in this problem in the bar chart. So once I have that, I can't get farther in the bar chart, but what I do have is an equation. That equation on the top, I take out whatever became 0. So that change of momentum, I take out and rewrite the equation on the bottom. So initial momentum of object 1 plus initial momentum of object 2 equals final momentum of object 1 plus final momentum of object 2. Well, I already found the initial momentum of object 1 and 2 right here in my bar chart. So I'm just going to fill those in. Obviously carried the negative in there. Solve on the left. And then on the right, I need to break this momentum 1 final and momentum 2 final up into mass and velocity. And then what I really need to do is realize that the problem says that they stick together and move, so they're going to have the same velocity. So I don't need this V1 and V2 nonsense anymore. So it just becomes velocity final. Then I need to fill in my respective masses. That didn't change, that I already know. Mass 1 is 80 kilograms times the final velocity. Mass 2 is 155 kilograms times the final velocity. Then I need to realize that those are similar expressions on the right side, so I can combine them. Then I divide by 235, crosses out over here. Calculator out. (15 kilogram meters per second divided by 235 kilograms. And final velocity is 0.06 meters per second to the right. I know it's to the right because it's a positive value. If it was to the left, it would be a negative value. And then what I can do is take this value and go fill out the final part of my bar chart. So if I know that in the final state, the masses didn't change, mass 1 is still 80 kilograms, and now I know it's moving at 0.06 meters per second, I do 0.06 times 80 kilograms. (4.8 kilogram meters per second). And then I know that mass 2 is 155 kilograms, and it's also moving 0.06 to the right, 0.06 meters per second to the right. So I know that is 9.3 kilograms meters per second. And to check myself, I need to make sure the left side of my bar chart and the right side of my bar chart match up. So if I just do some quick math in my head, 480 and negative 465 on the initial side equals 15 kilogram meters per second. And then over here, 4.8 with some general rounding, 4.8 plus 9.3 equals around 15 kilogram meters per second. So those need to balance, and they do. That is how you solve momentum problems. Now, what we're going to do next, if you guys want to finish writing this down and then get me that worksheet, the Dropbox is in this week's module. If you wanted to get me that, that'd be fantastic. These are the types of problems you're going to be expected to solve. This is the exact procedure you would use to solve them. And we're going to practice the first part first. I made these hand wrote this worksheet for you guys that we're going to do next. I solved the velocity parts for you. So you just have to make the bar graphs. That's where we're going to start with the practice. So I'm going to give you guys a couple minutes here. And I will get back to you in a minute once everything is submitted where it needs to be. All right, guys. So here is the impulse momentum bar chart practice sheet I made for you guys. It has 4 situations. I'll read them out to you. First one says ball 1 weighing 2 kilograms is moving 3 meters per second to the right, and ball 2, 1 kilogram, is stationary. The balls have Velcro on them, stick together, and start moving 2 meters per second to the right. I want a bar chart for that. 2, cart 1 weighing 10 kilograms is moving to the right at 2 meters per second. Cart 2 weighing 12 kilograms is moving to the left at 4 meters per second. When they collide, the carts stick together and move to the left at 1.27 meters per second. Need a bar chart for that. 3, a Toyota Camry has a mass of 1,000 kilograms and is traveling 4 meters per second east when it hits a 100 kilogram trash can. The trash can and car stick together and move 3.63 meters per second east. And then 4, a pool cue ball weighing half a kilogram is hit 6 meters per second to the north at the 14 ball, which is stationary. It has the same mass. The balls bounce off of each other, the cue ball stops moving, and the 14 ball begins to move 6 meters per second to the north. Give me a bar chart for that. So I have already solved, like I said, guys, I have already solved the final velocity problem. So what you need to do is just take each mass, multiply it by each respective initial velocity, and then take each mass and multiply it by their respective final velocities. There's nothing in this change in momentum column yet. I have a practice worksheet for Monday that will deal with that kind of problem. So if you guys could do this for me, that'd be fantastic. And if you have any questions, I'll be right here for you. I don't envision it taking, I don't envision it taking much more than 10, 15 minutes. Yes, it is official. We are back to, if you would like to be, we are back to full-time learning. Guys, I created a Dropbox in Canvas for this. What I want you to do is to submit it when you're done, and I will give feedback. I will grade it with feedback, how you guys are doing, what you have right, what you have wrong, so you know where you are in constructing these. That's my plan for today. And I will be giving you guys that feedback as soon as you submit, so you know right away how you're doing. That's my plan for today. Yeah, of course you can. All right, I've started to get some submissions. I am giving feedback, so please actively look for it. And class does end in about 10 minutes here, so I'm just going to be giving you guys feedback until the end of class. I'd like if you guys did all four.